The camera of the mind drifts above a living world. Deserts breathe in slow waves of heat. Forests trade light for air across canopies older than memory. Mountains rise from the bones of continents and weather themselves back to dust. Beneath the glitter of cities, steel, glass, and the white arteries of highways lies a library written in stone. Each page is a stratum, each sentence a fossil shadow, each punctuation mark a seam of ash. 4.5 billion years, bound without an author's name. Most pages tell familiar tales. Oceans advancing and retreating, volcanoes redrawing coastlines, ice carving valleys, and meteor fire cutting brief signatures into the crust. But the record is not a photograph. It is a palimpsest, scraped, rewritten, folded by pressure, drowned by seas, and subducted into the planet's slow machinery. If a chapter were erased, who would know? The cities of today gleam for an instant against that timescale. Glass returns to sand, iron to oxide, concrete to silt. Forest roots pry open foundations. Satellites fall as streaks and vanish as smoke. After 10 million years, even the grandest skyline becomes a rumor in clay. What if this has happened before? What if millions of years before humanity named the constellations, another intelligence walked these basins and ridges, built its brief geometry against the sky, and looked outward, then fell silent so completely that only chemistry remembers? This is the Silurian Hypothesis. Not a conspiracy, but a scientific question born of geology and astrophysics. If another technological civilization once existed here, would the Earth still bear its trace carbon isotopes bent by industry, synthetic residues trapped in sediments, subtle scars in climate's long pulse? If we cannot find them, how will those who come after find us? In the quiet offices of NASA's Goddard Institute for Space Studies, the hum of computers mingles with the muted shuffle of papers. Outside, Manhattan traffic rolls past, unaware that in this room, two scientists are preparing to ask a question that will stretch the imagination far beyond the skyline. The year is 2018. Gavin Schmidt, a climatologist and the Institute's director, is accustomed to looking backward in time, not through the lens of history books, but through ice cores, sediment layers, and chemical traces locked in the Earth itself. Beside him, Adam Frank, an astrophysicist from the University of Rochester, has his gaze set upward, toward the distant stars and the exoplanets that circle them. For years, Frank had been part of the search for life beyond Earth, not simply microbial life, but civilizations. This search, known in scientific circles as SETI, had always faced a silent puzzle. If advanced civilizations are out there, why don't we see them? One possible answer haunted him. Maybe civilizations rise and fall quickly, leaving only faint traces in the geological record, even on their own planets. In a conversation that would plant the seed of the Silurian Hypothesis, Frank and Schmidt began to invert the question. Instead of only asking, how would we detect an ancient industrial civilization on another world? They asked, could we detect one here, on Earth, if it had existed before us? The idea was not born from wild speculation, but from the sober realities of geology. The Earth's surface is not a static archive. Continents drift, oceans open and close, mountains rise and crumble. Even the most enduring monuments of our time, the pyramids, the Great Wall, the skyscrapers of New York, are mere dust in the measure of millions of years. Schmidt knew that almost nothing of human civilization would survive a span of 10 million years. Roads, bridges, glass, plastic, all would be broken down, scattered, or buried. Metals would corrode back into the crust. Even the satellites orbiting Earth would eventually fall, burning away in the atmosphere. If we searched for ourselves in the far future, we would find almost nothing. This realization reframed the question entirely. If a civilization had arisen in Earth's deep past, say 100 million years ago, what could possibly remain of it now? The answer, they reasoned, lay not in the bones of cities, but in the bones of the Earth itself. The Industrial Age changes the planet in subtle but measurable ways. A spike in carbon isotopes from fossil fuel burning, traces of synthetic molecules unknown in nature, layers of plastic fragments in sediment, sudden changes in biodiversity from habitat loss and climate disruption. These are not monuments, but signatures, chemical fingerprints that could, in theory, persist long after the builders were gone. And so, the Silurian Hypothesis took shape. If another civilization had once walked this earth, we would need to read its story not with the eyes of an archaeologist, but with the tools of a geologist, and the patience to listen to a planet's long memory. The first shock was not in imagining some shadowy, prehistoric empire, but in realizing how easily even our own civilization could vanish from the record. We like to think of our age as permanent. We have built towers of steel and glass, tunneled through mountains, laid down networks of concrete roads that crisscross continents. From the perspective of a single lifetime, they feel eternal. But to the Earth, they are as fragile as frost on morning grass. Geology does not keep our kind of time. In a few thousand years, our tallest buildings will collapse into rubble, their steel beams rusting to dust. In tens of thousands of years, forests will grow over the ruins. Rivers will meander across once bustling cities. Glaciers may come again to scour the land clean. In a million years, plate tectonics will drag continents to new shapes, burying what was once New York, Tokyo, or Cairo under kilometers of rock. By 10 million years, almost every trace of us, every artifact, every monument, every road will be gone. Schmidt and Frank ran through the sobering logic. If humanity disappeared tomorrow, a far future geologist, millions of years from now, would find almost nothing to prove we ever existed. Almost. Because while the surface evidence would fade, the planet itself might keep a quieter, more enduring record not in ruins, but in chemistry. Our civilization is leaving behind layers in the geological archive that nature alone does not create. The burning of fossil fuels is shifting the ratio of carbon isotopes in the atmosphere, oceans, and sediments. Plastics polymers unknown, before humans are sinking into the seabed in microscopic fragments. Rare industrial metals, spread across the globe from mining and manufacturing, are settling into the strata. And yet, these same kinds of chemical shifts have happened before. Volcanic eruptions can flood the air with carbon. Meteor impacts can scatter rare metals. Climate shifts can change isotopes and ocean chemistry. Which means that if there were an ancient civilization, millions, or even tens of millions of years before us, their chemical footprint might already be recorded in the Earth's rocks and ice, and we might have already mistaken it for something natural. That was the disturbing possibility. Not only might we never find them, we might have already seen their traces and dismissed them. It is a realization that collapses the comforting idea of human uniqueness. It asks, with unsettling quiet, to search for ghosts in the stone is to work in centuries, not moments. The tools are patient ones drills that bite into the ocean floor, ships that lower coring tubes into abyssal darkness, ice augers that bring up columns of ancient frost. In laboratories, scientists slice these cores like cake, each layer a thin slice of time. Some samples hold volcanic ash from eruptions that once blackened the sky. Others contain pollen grains from forests that no longer exist. And within the deepest layers, they read the chemistry of oceans long vanished, atmospheres long breathed by creatures we have never known. The Earth keeps its diary not in words, but in isotopes. Geologists turn to one period in particular, the Paleocene-Eocene Thermal Maximum, 56 million years ago. A moment when the planet's temperature rose by as much as 8 degrees in less than 20,000 years. Oceans acidified. Rainforests spread into what is now the Arctic. Countless species vanished, and others evolved in strange new forms. The cause remains a puzzle. The leading suspects, massive volcanic eruptions, the sudden release of methane from the deep ocean explain much, but not all. The carbon isotope shift recorded in the sediments mirrors, with eerie closeness, the pattern humans are now creating through industrial activity. This is where Schmidt and Frank's thought experiment gains its edge. If such a spike happened today, scientists millions of years in the future would likely see it as an event in the record. But could they know it was the work of a civilization? Researchers widen their search to other anomalies, layers enriched with metals like platinum or osmium, sudden planet-wide deposits of microparticles resembling soot, thin bands of sediments tinted with unusual colors, perhaps the dust of vast mining operations or industrial byproducts. Yet for every anomaly, there is a possible natural cause. An asteroid strike could spread metals. A megavolcano could change the air's chemistry. Climate cycles could shift ocean currents and temperatures in ways that mimic industrial warming. The deeper the cores are pulled, the more they whisper of a planet in constant upheaval, reshaping itself over millions of years, erasing and rewriting its surface story again and again. The search becomes less about finding them and more about seeing how invisible we ourselves will become. In the silence of those ancient sediments lies a mirror, showing a future where our own fingerprints fade, our monuments sink, and our name becomes nothing more than a chemical ghost. The deeper the question is asked, the stranger it becomes. For when we speak of a civilization, we instinctively imagine something like ourselves. Cities of stone and steel, languages etched into symbols, art carved in permanence. But the past owes us no such symmetry. If another intelligence once walked this earth, it might not have stood on two legs. It might have slithered, or swum, or glided on wings of flesh or bone. It may have lived not under the open sky, but beneath the crushing weight of the deep ocean. Its architecture dissolved into water long before the first mammal walked the land. If such a species had mastered technology, there is no guarantee it would have chosen ours. Their machines might have been woven from organic materials, leaving no trace. Their energy might have come not from burning fossil fuels, but from currents, tides, or even biochemical processes invisible to the geological record. In this light, our hunt for familiar signatures becomes less like detective work and more like chasing a shadow that has no fixed shape. And perhaps their fate was not a sudden apocalypse, but a slow fading. They might have turned inward, abandoning expansion, letting their cities crumble quietly back into the soil. Civilizations, like species, may have natural lifespans, and once their arc is complete, time grinds them into anonymity. Yet this idea cuts both ways. For if intelligence arose once before us, it could arise again after us. Perhaps Earth is not a lone, unbroken line from microbes to humans, but a cycle, a wheel that turns, lifting one species to dominance, then erasing it, then lifting another. And so the unsettling question grows sharper. Are we the first, or simply the latest flicker of awareness in a planet that has seen many? In the cold geological night, our lights are brief, and the silence beneath our feet might not be empty, only patient. Science thrives in the tension between what is known and what is possible. The Silurian Hypothesis exists in that liminal space, a thought experiment where the mind drifts millions of years backward into a darkness where the familiar scaffolding of human history vanishes. Some scientists hold the simplest explanation. There was no civilization before ours. Every odd chemical spike, every sudden warming event, every unexplained extinction can be accounted for by nature alone. Volcanoes, asteroid strikes, methane bursts from the ocean floor. The Earth has no shortage of cataclysms that can mimic the fingerprints of industry. In this view, the Silurian Hypothesis is a mirror held up to our own fears, not a window into a lost age. But another camp entertains the possibility not because there is direct evidence, but because absence of evidence is not evidence of absence. If plate tectonics and erosion erase nearly all surface traces within a few million years, then the fact that we have found nothing is hardly a final verdict. A civilization might have risen and fallen during the Paleocene or even earlier, leaving behind only whispers in the chemical record. There is also the cyclical intelligence model, the notion that the evolution of consciousness and technology is not a singular event but a repeating pattern. Like the blooms and extinctions of coral reefs, intelligence may flare across epochs, each time unaware of the ghosts that came before. Our own era might be just one flowering in a long, hidden garden. Some thinkers extend the speculation outward, suggesting that if life has visited Earth from elsewhere, seeded here intentionally or by accident, that lineage could have developed its own civilization before vanishing into the folds of time. In this telling, we might be the inheritors not of the apes alone, but of a much older cosmic ancestry. And then there is the quiet, more unsettling possibility that evidence of them might be right in front of us, misread as natural, dismissed as coincidence, filed away as unremarkable in some forgotten data set. In that case, the question is not whether they existed, but whether we have already seen them and failed to notice. The Silurian Hypothesis does not insist on an answer. It lingers like a shadow at the edge of light, reminding us that history is not a straight line, but a palimpsest, a manuscript written and erased, over and over, across the deep time of Earth. If the Earth is a book, then science is learning to read it in wavelengths beyond the human eye. Each instrument, another sense, tuned to whispers, too faint for our ears. In the search for traces of a pre-human civilization, the spade and brush of the archaeologist give way to the drilling rig, the spectrometer, the orbiting satellite. The clues we seek are not shards of pottery or weathered stone, but molecules, isotopes, and patterns carved into the planet's chemistry. The deep-sea sediment core is one of our most valuable archives. Lowered through kilometers of water to the ocean floor, it returns with cylinders of layered mud, each stratum a year, a century, a millennium. Locked inside are the trapped remains of ancient atmospheres, dust from distant continents, ash from eruptions, and chemical signals from unknown events. A spike in carbon ratios, anomalous deposits of heavy metals, the sudden appearance of molecules that have no known natural origin. Each is a line of code in Earth's memory, waiting to be deciphered. From the poles, ice cores offer another record, bubbles of ancient air sealed under crushing weight, some more than 1 million years old. The ratios of gases within them reveal planetary breaths, warmings and coolings, and perhaps moments when the atmosphere bore an unnatural fingerprint. Above, satellites map the scars and folds of the continents in exquisite detail, revealing shapes that might be riverbeds, ancient shorelines, or improbably structures buried under deserts and jungles. LiDAR technology strips away vegetation to uncover hidden geometries on the ground. While most are the remains of our own human ancestors, there is always the possibility, however remote, of finding something that does not belong to our chapter of history. Artificial intelligence now combs through terabytes of geological data, looking for patterns that human eyes might dismiss. It can connect anomalies across oceans and continents, linking an unexplained carbon spike in Antarctic ice to a strange metallic trace in Pacific sediments, both from the same forgotten moment in deep time. And in the ultimate irony, the tools built to search for alien civilizations, spectrographs designed to detect industrial gases in the atmospheres of exoplanets, are now being turned inward, applied to our own Earth's ancient record. Mars, Venus, distant exoplanets, and Earth itself become part of the same cosmic survey. We may never find conclusive proof, but with each passing year, our instruments grow sharper, our data sets deeper, our vision more attuned to the subtle language of planetary history. Somewhere in that language, if the Silurian Hypothesis is true, the Earth may yet speak. Beneath our feet, the Earth keeps its secrets well. The continents drift, oceans swell and vanish, mountains rise and wear away, And the record of what once was is folded back into the deep erased, not out of malice, but out of the slow, unyielding rhythm of geology. If another civilization walked this planet before us, if they gazed at the same moon, feared the same storms, loved and grieved beneath the same stars, their monuments are gone. Their words, their art, their maps, their songs, dissolved into the silence of stone. Only the faintest chemical whispers may remain, indistinguishable from the breath of volcanoes, the soot of wildfires, the scars of asteroids. This is the heart of the Silurian Hypothesis. Not just the possibility that we are not the first, but the certainty that the Earth erases. That one day, it will erase us too. Our skyscrapers, our satellites, our entire age reduced to a layer a few centimeters thick in some future cliff face, studied by hands that may not be human. And so the question lingers. If the story of intelligence has been written here before, then perhaps it will be written again. Not once, not twice, but countless times, across eons longer than we can grasp. We may be a fleeting verse in a poem that spans hundreds of millions of years. If that is true, then we are not the pinnacle of Earth's story. We are simply its latest chapter. And one day, another reader will turn the page.